try to solve this problem, in which we can see there are two plants are there, namely A and B, and three warehouses are there, P, Q and R. Okay, so the capacity of plant A is 875, capacity of plant B is 575, demand at warehouse A is 350, demand at warehouse Q equals 350, and at R is 450. So that's the given question. So as we know, these are the cost element. The first step is that we can calculate the demand equals supply. So when we calculate the demand equals supply, so the step 1, okay, so step 1, calculate demand equals supply. So when we calculate the demand equals supply, when you total the capacity 875 plus 575, we will get 1450, and when we calculate the demand, we will get a value of 1150. So it proves that the demand is not equal to supply. So we can see that the excess is capacity here, okay, and the lesser quantity is demand. So in order to ensure demand equals supply, add a dummy column. Okay, add a dummy column having a demand of 300. Okay, having a demand of 300, that's the difference between 1450 and 1150. So you can see to that by adding a dummy demand of 300, both demand will equals to supply. Okay, so add a dummy column to ensure demand equal supply. Now by adding a dummy column, we can see to that the total demand is equal to the capacity, that is demand and supply is added. So the added dummy column will have cost elements which is equal, the cost value of that will be equal to 0. So that you can see over here, the dummy cost value is 0 here and 0 is entered over here. Now demand equals supply, we can go and find the initial solution. So initial solution, as we have discussed, we can go for either northwest corner rule, or we can go for least cost method, or we can go for Vogel's approximation method. So we have seen that if we are going for Vogel's approximation method, we will get a near net solution easily, so that our optimality conditions we need to work only less. So in that case we are going to find the initial feasible solution with the help of Vogel's approximation method. So for finding the initial solution by using Vogel's approximation method, we know that we need to calculate the row difference and we need to calculate the column difference. So the lowest between the two lowest cost elements we need to consider. So row wise 15 and 0. So it will be 15 minus 0. So here it is 0 and 10. So it will be 10 minus 0. And similarly the column difference. So column difference is 10 and 35. So 10 and 35 here. Next is between 20 and 25. That is written here. Next is 30 and 15. So that value is also written here. Next is 0 and 0. So row and column difference we have calculated, and we need to select, okay, the largest difference. So the largest difference among 15, 10, 25, 5, 15 and 0 is 25. Okay, and so we need to give the allocation for our first column P. So among the P, we need to identify among the cost elements, identify the lowest cost element. The lowest cost element is 350. So give the assignment to the lowest cost, that is 10. So lowest cost is 10 here, and if we see the corresponding demand and capacity, 350 is the demand and 575 is the capacity. So allocate that 350 over there, allocate 350 over there. So what happens? We can say that that particular column will get cancelled. So that particular column will get cancelled. Okay, that particular column will cancel, and the balance here, okay, the balance there will be 225. Okay, so that is gone. The new balance will be 225. Okay, so now go for the next iteration. Okay, go for the next iteration. So we have marked over here. So now, so this is cancelled. We have, instead of 575, we had 225. So we can calculate the new row difference and column difference. So row difference and column difference. So if we see, so it will be 15 minus 0 again here. So 15 minus 0, value will be 15. Here it will be 0 minus 20, 20 minus 0, value will be 20. So here it will be 25 minus 20, so it is 5. Here it is 15, 30 minus 15, so value will be 15. So if we see, the largest difference is 20. Okay, largest difference is 20. So in that, the lowest cost is 0, where we can see the demand is 300 and it has a capacity of 225. So we can allocate that 225 over here. We can allocate that 225 over here. We can see to that the row B will get eliminated from our set of calculations. Okay, so the balance figure here, it will be only 75. So the balance amount, instead of that 300, it will be only 75 only will be left out here. Okay, so now I'll take to the next sheet. So if we see over here, again we can go for row difference and we can go for the column difference. So we can go for row difference and column difference. So again this will be 0 minus 15 will be 15. Here the value is 25. Here the value is 15. Here the value is 0. So largest difference is 25. The condition is 350 over there. So allocate that 350 over here. Allocate the 350. Okay, so the second column will also get eliminated right now. Okay, Column will also will get eliminated. So this will be something like you will have so you will have 5 here, 2, 5, 525 will be left out. So on the next step, okay, so that will be, so now this is your third entry, okay, this is your third entry. Now fourth entry, if we see, again it is 0 minus 15, 15, here it is also 15. So the priority will be given to your first row. So first row, the lowest element is 0, where the capacity is 525 and demand is 75. So you can allocate that 75 there. Okay, you can allocate that 75 here. Okay, when you allocate that 75, so that column also will get, that dummy column also will get eliminated. Okay, so that was your entry number 4. So the balance here minus 75, it will come as 450. So you can see over here only one is left out, 15. So that 450 you can assign over here. So that is 450. Okay, so this is the initial solution. So this was dummy. Okay, so this is the initial solution by Vogel's approximation method. So transportation cost, so transportation cost will be equals to, okay, transportation cost will be equals to 25 into 350, 25 into 350 plus 15 into 450 plus 75 into 0 plus 10 into 350 plus 0 into 225. So the total value will be rupees 19,000. The initial cost value is rupees 19,000. Okay. Now the next step is that we need to check the obtained solution. The obtained initial solution is feasible or not. The obtained solution is feasible or not. So I'll just I'll just write the values, the copy the allocation alone over here. So we have 350 and 350 here. So here it is 350, here it is 350, then it is 450 here, we have 75 on the top and 225 in the bottom as our allocations. Okay, right. Okay, now we'll go for checking the optimality. Okay, checking the optimality. So in checking the optimality, okay, the first step, okay, step 1, check the initial solution. Initial solution is degenerate or not. How we will check? We have known the equation m plus n minus 1, m plus n minus 1 should equal to number of allocations. So here the m is the number of row and n is the number of columns. So we have m value as 2. So 2 plus 3, we have 2 rows and 3 columns. So 2 plus 3 minus 1. And number of allocations we have 1, 2, 3, 4 and 5. So the problem is non-degenerate. Okay, the problem is non-degenerate. We can go for the calculations. Okay, we can go for the calculations. Okay, so this is 350, 450. We have 75 here, 225 here, 350 here. Okay, so we can go for the calculations. So I'll take the next sheet to calculate it. So this was our initial solution, so we can calculate it. Okay, so initially we are going for UV decomposition method. Okay, or modified distribution method, also known as MODI method. So in that case we know that, so this will be taken as U1, this is taken as U2, this is taken as V1, this is taken as V2, this is taken as V3 and this is taken as V4. Okay, we'll just draw the table for the calculations. So stone square, equations and calculations. So stone square, equation, and we have our results. So what are the stone squares here? So we had the stone squares as AQ, we had AQ, AR, we have DAD, then we will have BD, we will have BD, then we will have BP. So the equation for AQ will be U1 plus V2, U1 plus V2 equals 25. Next one, U1 plus V3 equals 15. Next is U1 plus D equals, okay, U1 plus, U1 plus V4 equals 0. Next one, U2 plus V4 equals 0. And then U2 plus V1 equals 10. So when you solve, you can see to that this will give initial assumption U1 equals 0, so V2 will be equals 25. Okay, since U1 is 0, V3 is 15, here it is V4 is 0. Since V4 is 0, U2 is also 0. Since U2 is 0, V1 equals 10. Okay, now we will calculate the net cost change. Okay, we will calculate the net cost change. Okay, so net cost change we will calculate it for water square. Water square we have equation and we have solution. Okay, so we are now calculating the net cost change. Okay, so the water square in our cases will be AP, then we will have BQ, and then we will have BR. So the equation will be C of AP minus A is U1, so U1, and P is V1, so U1 plus V1. So which implies 35 minus, okay, 35 minus U1 value we have solved, U1 is 0, so 0 plus, okay, so I'll write it on the other side. So that is 35 minus U1 is 0, we have calculated here, and V1 value is 10. So 35 minus 10, we'll get it as 25. Then BQ will be C of BQ minus, it is U2 plus Q is V2, U2 plus V2. So C of BQ is 20, so 20 minus U2 value we have calculated as 0 plus V2 value is 25. So we'll get it as, once you solve, we'll get it as minus 5. The third is C of BR minus U2 plus R is V3. So C of BR is 30, so 30 minus U2 is 0 plus V3 is 15. So 30 minus 15, it is 15. So we can see to that, the condition is that if any negative value is that, negative net cost change indicates a better opportunity exists over our present solution. So we are getting minus 5 over here. It means that the initial solution or the previous or the present iteration or the previous iteration solution is not optimal one. So optimality is not that one. There is a better solution is existing. So we need to find it out. So now we know that the next step is to form the closed loop starting from BQ. Okay, so let me select this and add to the next page. So now forming the closed loop. Okay, so step is to forming closed loop from BR. Okay, BR, sorry, from BQ. BQ we got it as the negative, sorry. From BQ. Okay. So BQ, if you want to form a closed loop starting from BQ, So to AQ, okay, from AQ to dummy, that is AD, AD to BD, and then close the loop. Okay, so next step is to add positive and negative negative from starting from the selected water square. So if selected water square is BQ, so that is positive, this is negative, so this is again positive, this is again negative. Okay, now we need to select, okay, now we have added alternate plus and minus sign. Okay, add alternate plus and minus sign starting from selected water square. Okay, so next step, our next step is to find lowest negative coefficient. Okay, subtract wherever negative sign is there and add wherever positive sign present. Okay, so the lowest negative here is minus 225. So minus 225. So here it will be 75 plus 225. Okay, here also that 225 you need to move. 225 you need to move. The new value here will be 0. And when you are moving the 225 over here from 350, that 225 needs to be subtracted. So this will be minus 225. And this 450, you can see that here I am only passing the loop. Okay, I am not, this is not any junction point. Since it is not a junction, please don't change the assignment here, or please don't add any signs here. You are just passing through it. So leave it as it is. Wherever it forms as a junction, that point only you need to add plus and minus over there. So you will get a new solution. So you will get a new solution. So the new solution, whatever is shown over here, you will get the solution like this. Okay, so it is 125 over here, 225 here, 350 here, 450 and 300 you will get as a solution. Okay, so you can see over here, or so you can see over here. So this will be 350 minus 225, 350 remains here, 450 remains here, this will be 300. So that's the solution. So you got the new table. Okay, so you got the new table with allocations of AQ as 125 and BP as 350, BQ as 225, AR as 450 and A dummy as 300. Now again the stone squares are AQ, AR and AD, and we have BP and BQ. The new water squares are AP, you will have BR and BD. Now you calculate the U and V decomposition for it. Okay, U and V decomposition for stone square. I have already calculated it here. So when you calculate it, you can solve, you can get the corresponding U and V values. So calculate the net cost change. Okay, calculate the net cost change for water square. So water squares are our AP, BR and BD. Okay, AP, BR and BD. So when you calculate, you can see the values becomes positive. The values becomes positive. So value become positive means the what you have got in that particular iteration, that value is optimum one. Okay, the solution whatever you have got is optimum one. So you can calculate the transportation cost. So transportation cost will be 25 into 125. Okay, so transportation cost will be 25 into 125 plus 15 into 450 plus 0 into 300. So I am leaving it. So 10 into 350 plus 20 into 225. So if we calculate it, we will get the value as 17875. So value is 17875. Okay, and that value becomes optimum. Okay, the final value is 17875 and that is our optimum value. So this is how we will solve a problem. This is how we will solve a problem which is basically unbalanced in nature. Okay, unbalanced problems are solved by adding a dummy row or dummy column, whatever is appropriately needed in that problem you can add and solve. So I will stop here. We will see in the next class.